Okay, in this video, we'll look at a couple of the questions from the 1.2 homework. So we're going to start with number 5. Okay, so number 5 is just, we're finding this limit. And remember, the whole point of this is we're going to do this without a graph. Well, what's a great way to start? Remember, a great way to start is just to go ahead and plug in the value, see what you get. So if I plug in this value, I get, let's see, negative 8 cubed plus 512 over negative 8 plus 8. Well, guess what negative 8 cubed is you get negative 512. Remember, when you raise a negative to an odd power, the negative stays. So I get negative 512 plus 512 over negative 8 plus positive 8. And sure enough, I get 0 over 0. Remember, what does 0 over 0 tells me? It's indeterminate, which means I got to keep going. There's more to do. How can I manipulate this to hopefully get to a more concrete answer? Well, any ideas? I talked about 3 tools in my example video. This one, it turns out, I'm just going to be using factoring. X cubed plus 512 does factor. And this one, it's not super obvious. This one, it might be helpful to look up how to factor cubed numbers, because here you have 2 cube numbers that are being added together, right? You've got x cubed and you have 8 cubed. So you can look that up. What do I get when I actually factor this? I had to re-record this 3 times because I thought I knew it, but I had to actually go look it up. You get an x plus 8 in the numerator. You can factor out an x plus 8, which makes sense because I want to be able to cancel out the x plus 8 in the denominator, right? That's what's causing my problems. And so it makes sense that I'm going to be able to factor out an x plus 8. But what am I left with? I'm left with an x squared minus 8x plus 64. Right? That middle term needs to be negative in order to cancel out the middle terms. And that's all over x plus 8 still. Perfect. Why is this helpful? Because now this x plus 8 factor cancels out with that x plus 8 factor. And you're left with just this limit as x approaches negative 8 of x squared minus 8x plus 64. Once again, now I've eliminated the denominator, which was what was giving me my undefined value. X squared minus 8x plus 64 is continuous at negative 8. So to evaluate this limit, I just need to plug in negative 8. So I get negative 8 squared minus 8 times negative 8 plus 64. Negative 8 squared is positive 64. Minus 8 times negative 8 gives me a positive 64. And then plus another positive 64. Woo, what is 64 times 3? I get 192. So the limit does exist, and it's equal to 192. Okay, well, let's look at another problem for the homework. This is number 14. You may have noticed that the second half of the homework is more asking the question, well, is this function continuous at a certain x value? And the way we're going to answer that is by really going through those 3 criterias that have to be true in order for the function to be continuous. So let's think about those 3 criteria. First of all, the function value has to exist. So in our case, we're looking at x equals 5. So does f5 exist? Well, notice if I look at my qualifiers for this piecewise function, this bottom one is for if x is greater than or equal to 5. So if x is equal to 5, do I have a rule to plug it into? Sure enough. I sure do, right? If x is equal to 5, I use this bottom term. So f of 5 is just equal to 4 times 5 minus 5, so it's equal to 50. Okay, criteria 1 is satisfied. The function value does exist, and that's mostly because, once again, I have this greater than or equal to term. Okay, 2. What needs to be true for condition 2? Well, for condition 2, I need to make sure that the limits from either direction are the same. So the limit coming from the negative direction and the limit coming from the positive direction of my function. Okay, so I have to make sure that the limits from both sides will equal the same thing. Well, how do I check that? Well, let's start with this top one. If x is approaching 5 from numbers less than 5, let's see, that's numbers like 4.9, 4.99. If I were to plug numbers like that into my function, which rule would I use? Well, if x is less than 5, I'm supposed to use this top rule. So what happens is this effectively becomes the limit as x approaches 5 of this function. I'm going to use this rule because I'm exclusively working with numbers that are less than 5. Okay? So if I use that rule, if I try and plug in 5, I get 0 over 0. I get an indeterminate value. So what does that tell me? That means I'm probably going to be using one of either factoring, conjugates, or combining a fraction. Which one do you guys think we're doing here? Probably factoring. Ooh, man, so how does this one factor? If you're not sure how to start, if you're not sure where to start, guess what's probably going to be a factor? X minus 5 is probably going to be a factor. So can I factor out an x minus 5? Well, let's see. If I factor out an x minus 5, then this term has to have a 2x in it, because that's how I'm going to get the 2x squared term. So this term has to have a 2x. And since I factored out a minus 5 out of this term, what am I left with? I'm left with a plus 5. Because positive 5 times negative 5 gives me that negative 25. So if we want, that gives me my second term. If we want, I can double check to make sure that's correct. X times 2x gives me 2x squared. X times 5 gives me plus 5x. Negative 5 times 2x gives me negative 10x. And then negative 5 times 5 gives me the negative 25. What is positive 5x minus 10x? I get a negative 5x. So sure enough, it works. So I've factored that top term, and I have factored it in a way, well, it factors nicely so that one of the factors matches the denominator, and those then cancel out. This leaves me with the limit as x approaches 5 of just 2x plus 5. And once again, since 2x plus 5 is just linear and continuous, I can go ahead and just plug in 5, and I get 2 times 5 plus 5, which is equal to 15. So my first limit is equal to 15. My limit from the left direction is equal to 15. Now we got to check the limit from the right direction. Well, if I'm coming from the right direction, that means I'm coming from numbers slightly bigger than 5, like 5.1 and 5.01. If I'm coming from numbers bigger than 5, which rule do I use? I use the bottom rule. I use this one. I get the limit as x approaches 5 of 4x minus 5. Well, this one's nice because I don't have any extra work to do. 4x minus 5 is already a continuous function. I can go ahead and plug in 5, which guess what? You guys have already done. And you get 15. So does the limit from the left side match the limit from the right side? Yes, they do. So it's official. The limit as x approaches 5 from the negative side equals the limit as x approaches 5 from the positive side. So criteria 2 is fulfilled. What about criteria 3? Criteria 3, we just have to make sure that the limit that we just found, what was that limit? That limit was 15. We have to make sure that that limit we just found matches what we got in part 1. So is that true for us? The limit as x approaches 5, since it was the same from both directions, it exists and it was equal to 15, and that equaled the function value. And so that satisfies criteria 3. Since all 3 conditions are satisfied, the function is continuous. Now, so it's one of these 2 options, right? It is continuous. It's continuous. We just have to make sure that we check the right one. And look at that one. Where does that look familiar? That's exactly what criteria 3 is. F of 5, you'll notice that the other reasoning is that f of 5 doesn't exist. Well, that would disqualify it from being continuous. In order for it to be continuous, f of 5 does have to exist. So in our case, the answer is C. Okay, let me know if you have any other questions on the homework, and I'd be happy to help you out. But have a great day.